This is lesson 9-2, sample spaces. Here's a probability game for two players. Place 2 green marbles in bag A. Place 1 green and 1 red marble into bag B. Without looking, player 1 chooses a marble from each bag. If both marbles are the same color, player 1 wins a point. If the marbles are different colors, player 2 wins a point. Record your results and place the marbles back in the bag. Player 2 then pulls a marble from each bag and records the results. Continue alternating turns until each player has pulled from the bag 10 times. The player with the most points wins. Make a conjecture. Do you think this is a fair game? Yes, I believe it is. Here are our possible outcomes. Player number 1 will draw a green marble from the first bag. That's all there is. He can draw a green marble from the second bag, which means he wins. He's going to draw a green marble from the first bag all the time. He could draw a red marble from the second bag, which means player 2 wins. Player number 2, again, has only one choice in the first bag. He must draw a green, that's all there is. He could also draw a green marble from the second bag, or he could draw a green marble from the first bag and a red marble from the second bag. As you can see from this really simple example, there's 2 ways that player 1 can win and 2 ways that player 2 can win, so the game is fair. Now, question number 2, without playing the game, who would win? Could you predict who is going to win? No, this is theoretical probability. Doesn't always match experimental probability, which is what you'd get when you play the game. So we'll explore that in a further lesson, but the question mainly is the game fair? And yes, it is. A vendor sells vanilla and chocolate ice cream. Customers can choose from a waffle or sugar cone and either hot fudge or caramel toppings. Find the sample space for all possible orders of 1 scoop of ice cream in a cone with 1 topping. Make a table that shows all of the possibilities. Well, here is our 4 possibilities if we choose vanilla, and our 4 possibilities if we choose chocolate. Notice it's vanilla waffle hot fudge, vanilla waffle caramel, vanilla sugar hot fudge, vanilla sugar caramel. These outcomes right here are exactly the same whether we have vanilla or chocolate or ice cream. The animal shelter has both male and female Labradors in yellow, brown, or black. Find the sample space for all possible Labradors available at the shelter. Well, we have male yellow, male brown, female brown, male black, female black. That would be our sample space. A tree diagram can also be used to display the sample space. A car comes in silver, red, or purple as a convertible or hardtop. Which list shows all the possible color top outcomes? In this case, it would be example A, because we can have silver convertible, silver hardtop, red convertible, red hardtop, purple convertible, purple hardtop. We're missing possible outcomes in all of the other 3. The car comes in 3 colors with 2 tops. Find all the color top combinations. What they've done here is take the table from A, make it in a tree diagram. We can have silver convertible, silver hardtop, red convertible, red hardtop, purple convertible, purple hardtop. And you can see those same outcomes in this table. For dessert, you can have apple or cherry pie with or without ice cream. Which list shows all the possible outcomes of choosing pie and ice cream? Well, we can have apple with ice cream, apple without, cherry with, cherry without. The correct answer that shows all the possible outcomes here is choice G. You can use a table or a tree diagram to find the probability of an event. Remember, probability is favorable outcomes to possible outcomes. Refer to the mini lab at the start of the game. That's where we were drawing the marbles out of the bag. Remember, we had 2 green marbles in the first bag, a green and a red in the second bag. There are 4 equally likely outcomes. That's the key right there. That's what makes the game fair, is those outcomes are equally likely. Player number 1 can draw a green, or must draw a green, can go green, 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 red. Player number 2 must draw green. He can go green, green, or green, red. So player number 1 wins half the time. Player number 2 wins half the time. This is where player number 1 wins. This is where player number 2 wins. So the probability that A will win or player 1 will win is 1 and 2, exactly the same as it is for player 2. Marcos tosses 3 coins. If all 3 coins show up heads, Marcos wins. Otherwise, Kara wins. Find the sample space, then find the probability that Marco wins. Well, here's coin number 1. It can be heads or tails. Coin number 2 can be heads or tails. Coin number 3 can be heads or tails. These are all our possible outcomes in a tree diagram. You can see here that only 1 in 8 possible outcomes do all of the coins turn up heads, meaning there are 8 equally likely outcomes, only 1 of which favors Marcos. He can win based on the probability only 1 in 8 times. Not good. For each situation, find the sample space using a table or tree diagram. A number cube is rolled twice. A pair of brown or black sandals are available in sizes 7, 8, 9. Here's a cube that's rolled twice. We can add 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2. There are, I believe, 36 possible outcomes here. We can have brown 7, brown 8, brown 9, black 7, black 8, black 9. 6 possible outcomes. Sandwiches can be made with ham or turkey on rye, white, or sourdough. Which list shows all the possible outcomes? We have ham or turkey, rye, white, or sourdough. Ham, rye. Turkey, rye, ham, white, turkey, white, ham, sourdough, ham, or turkey, sourdough. Our correct answer here would be C. Two meats, 3 breads, 6 possible outcomes. Number 4, Brianna spins a spinner with 4 sections of equal size twice, labeled A, B, C, and D. If letter A is spun at least once, Brianna wins. Otherwise, Odell wins. Find the probability that Odell wins. Because there are 4 sections and 4 spins each time, or 4 possible outcomes each time, that means there are 16 possible outcomes. You can see from here the possibilities where A occurs is 7, 1, 2, 3, 4, 5, 6, 7. That means of the possible 16 possible outcomes, Brianna can get 7 favorable outcomes. Odell gets 9 favorable outcomes. So the probability that Odell will win is 9 in 16. 2 possible vocabulary in this lesson. They are sample space, which is the set of all possible outcomes of a probability experiment, and a tree diagram, which is used to show the total number of possible outcomes in a probability experiment. Students must put these in their notables and memorize them for the Chapter 9 vocabulary quiz. At this point, you should stop the video, go to NICU at www.nicu.net, and watch or take lesson quiz 9-2. Thanks for watching.